ABB claims that their industrial drive, ACS880, provides uncompromised productivity. I say, let's put it to the test. Ever heard about a bull in a china shop? Sure, but how about a 6-ton elephant?
For accurate control, information about motor speed and torque is essential. This is usually provided by external devices such as encoders or resolvers. In this test, there are none. We have 3 ACS880 drives controlling the 3 electric motors of the crane, all without feedback devices.
ABB claims that everything you need for extremely accurate control is already built into the drives, and that means you're saving money and space.
Plus, you get better control over your process. Uncompromised productivity, as we like to say.
Mike, you work for ABB, so I'm not going to take your word for it. I want to see for myself. Bring in Jimbo! Not exactly a ballerina, is he?
He's obviously been eating well, and at over 2 meters wide, he barely squeezes between the shelves.
And now he has to pass through 64 meters of test track.
And over 720 shelf meters of china ready to be smashed into pieces.
Okay, Jimbo, let's go shopping. So far, so good.
Yes, this is the easy part. Now we're getting to the corner.
You're slowing down.
Yeah, that's because I can. That's one of the advantages of DTC. You can drive very slowly and maneuver very accurately at the same time. DTC sniffs its stator's flux and motor current and uses the information to calculate the required torque and speed. If the values don't match with the target, DTC balances the motor back to its track in less than 20 microseconds.
Good boy, Jimbo. You said that DTC gives highly accurate control at low speeds.
Sure, the drive has very high static and dynamic speed accuracy.
Right, can you drive and control it at like really low speed?
Even with no speed.
But that doesn't make sense.
Sure it does. What it means is that you can start up the motor at full torque. This is the trickiest situation you can have for your crane.
The trickiest? Let's test it. Let me introduce you to Mr. Minghead. We're going to witness an experiment that ABB does not recommend. The movement of the hoist must always be secured by feedback that guarantees correct performance. In this case, however, we will see an exception in order to demonstrate DTC's capabilities. Okay, we want to lower Jimbo now onto Mr. Minghead's head. That's it, gently does it, you don't want to hurt Mr. Minghead. And stop. Now apply the brake. So, the mechanical brake holds Jimbo in place, and Mr. Minghead is safe so long as the brake is engaged, right?
Yeah, correct. The thing is, even if the brake fails, DTC will still save our brave man.
Because DTC recognizes the new situation in microseconds.
Exactly.
Okay, 3, 2, 1, go. He is safe. Good boy, Jimbo. Sorry, yeah. Way to go, drive. I'm disappointed. That was too easy.
It was only easy because of DTC. With any other drive, we'd be sweeping up bits of china right now.
Well, maybe it was the application. How does the drive work with a winch or a conveyor or any other application?
Trust me, the drive has specific control programs for numerous applications. So Uncompromised Productivity is available for any typical industrial application, even for potentially explosive atmospheres.
Well, I have to say, Uncompromised Productivity sounds a little bit gibberish.
The whole idea of this drive is to control processes as efficiently as possible, saving electricity and boosting productivity. With some applications, they can save up to 60% of energy costs.
60%?
Only if the drive is operating as it was meant to be.
I think I'm going to have to say it now.
I think you should.
Does ABB's ACS880 drive provide uncompromised productivity? I say it does.